Okay, so what you guys are gonna have to do for next week is the review lab. As it says here in the text above it, it is due next week for class. I don't think the review lab is all that hard. You just read it. What do you guys got to do? Let's see. Oh, yeah, this should be easy. This is like a really easy review of, oh, wait a second. This has inheritance in it. And you guys didn't learn about inheritance. Okay. You're not going to do this lab. I'm going to temporarily hide this thing on iLearn so you guys can't see it. Because some of these review labs and stuff are from last semester before we changed how the course was set up. So some of these have topics that you guys did not learn this semester, namely inheritance. You guys have not got to inheritance yet. So we're gonna just go ahead and hide this section, and we'll hide this section too. Hi, doggo. What's wrong? Cool. Cool. So, with none of that distracting you, let's get to what we're doing today. So there's a couple of options. I can sit and I can answer questions about the game project, or I can sit down and we can do some live coding together and we can try to build something. It's up to you guys. What would you guys prefer to do? You guys need to pick one because I'm live coding. Okay. What should we build? What do we build? What should I build? Rather, think of like a very simple application. What's something very simple that we could build? A game. Okay. Oh, I have an idea. Okay, so what I'm going to do is build a very, very simple game. Let's make a new demo over here. We could make a Sudoku game. We could do a Sudoku game, but I don't know if a Sudoku game is going to be a great example of objects. What I was going to do was make a blackjack game. So let's go ahead and, oh yeah, I'm going to do that. Just make a blackjack game. A text-based blackjack game. Close blackjack. Okay. Close all these up. All right. So let's think about all the parts that go into a game of blackjack. What's all in a game of blackjack? What are some of the pieces that we have in the game of blackjack? And I'll pull up the whiteboard and we can start writing them down on here. What do we got? Okay, so first of all, we got cards. That is the smallest part. Yep, cards. And for the cards, we've got 4 suits, 13 cards per suit, for a total of 52 total. All right, so those are cards over there. Got spades, etc. I'm not gonna write it all down. You guys know how cards work. What else? What is another small piece of the game? You guys are going way too micro. What I'm asking you guys is So when you look at your games that you guys designed, we split it up into small parts, right? You got your monster, you got the items in your game, etc. Like these are the small parts of your game. Likewise, what are the small parts of a blackjack game? There could be a dealer object, yes. That could be one. Yeah, we should have a hand for the player's hand. Player turns would not necessarily be an object we have, Ronnie. I mean, let's think about that for a second. What would the goal of a player turn be? If we had a player's turn object, what would the goal of that be? And I'll show you why we don't necessarily need it. You could implement it where you have an object that has the all the methods for that, but I could also just as easily have my methods in the player class, for instance. No, that's poker. Blackjack is where you try to not get, or you try to get 21. Okay, so for now, let's pause and let's just take a minute to write up our, I'm gonna write up the cards class. Now, bear in mind, as I code all of this is never, ever the only way to do it. There are always multiple ways to do this, right? But for our purposes, I am gonna this is how I'm gonna do it. So I'm gonna have a few, and because I'm making this off the top of my head, if I ever went back to this code and revisited it, it would probably be different. I would probably make changes and little differences, maybe like get rid of some redundancies in some places. But when I'm live coding, it might not be my best. So we're gonna see. So it's gonna have, and just for getting you guys used to using getter and setter methods, I am going to use different access levels. So some of these will be private, some of them will be public. So let's say public string, suit, and value. We're gonna have these two public variables, so private Boolean in use, or in play, I should say, face up. Ducta, 100% ducta. Actually, let me see. Who's teaching 220 next semester? Class schedule. Yeah, Ducta, I've had him. He is amazing. Oh, that's not it. Let's see, class schedule. There it is. That's not it. Let's see, class schedule. There it is. I mean, I've had him for an 8 a.m. back when I had to commute to campus from Pleasanton. If I can have him at 8 a.m., you'll be fine. You have to try really hard to fail his class. I kind of modeled my class after his. You have to try really, really hard to fail my class. I'm not familiar with Professor Zhu. Ducta is teaching a few. I don't know any of these others. Yeah, I don't know any of these other professors. Listen, it's remote classes. What are you complaining about with 8 a.m.? Get out of here. If it's in play face up, and then just to generate it, we're going to have private string arrays, values, which is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, Ace. Private
You have both ace and
string.
one.
Was it?
You have both ace and one.
Yes, you are correct. Thank you. I use suits, spades, aces, clubs, and hearts. Cool. And you guys will see why I use this in a little bit. Public card, int I value, int I suit, and suit is equal to value is at I value, and then what's value? Value is equal to I value. Suit is equal to suit at I suit. And we'll just say when we first created in play equals false and face up is equal to false. I don't necessarily have to initialize these right away, but I'm going to just in the event that something goes that I don't expect it and I don't want my program to crash because I try to query a null value. But again, this is because we're assuming that our version of Java isn't smart enough to, when we compile the program, we're going to assume it's not smart enough to set a default value for these things, and we're just going to assume it's going to be null to start. So that's why we want to make sure we explicitly define a value to it so that things don't go wrong. And I'm not going to make a default constructor because I'm not going to use a default constructor for this class. So here we go. Public string get card. Yeah, sure. Get card is gonna just return suit of. Actually, I'm gonna say string toString. ToString is a default Java method. So if I had like something like, say, I'll just write it in here, int x is equal to 3, and I wanted to treat x as a string, I would say string xs is equal to x dot toString. Java already has a default. Oh wait, no, it's not a toString. It's string dot or parse int, right? Or something like that. There is an actual like toString that you can use. I can't remember off the top of my head. Sorry, I've been writing JavaScript for the past like however long, and some of the like it's similar, but some of the methods that exist in JavaScript aren't the same in Java. Anyways, and then we'll say, value of suit. So we'll get like A of clubs, for instance. Will be what this will return. And then we're going to have, oh, it wasn't working here because, okay, yeah, I know why. Because we had explicitly overridden the toString. But if I didn't do that, and I had int x is equal to 3, and then x dot toString, no, whatever. There was a way to do it. I can't remember now. But anyways, let's just say at override, because this is technically a default Java method that we're overriding with our own personal implementation. So let me see, what else? What are some other things that I need? Oh, I need, oh, that's not what I need. Public void deal card. No, we'll do that later. Public void set face up. Boolean face up. This dot face up is equal to face up. Cool. And we'll also do the same for our set in play, in play, in play, in play. Cool. Cool, cool. We have setters for those. We don't necessarily need getters for these because we already have this, but actually, no, we might want getters for it. In blackjack, the suit doesn't really matter, but the value is what matters. So I'm just going to have public string get value, and then it's going to return value. I'll just stay consistent with my formatting and do it like this. One of the things that I already know that I want to think about is in blackjack, an ace can be a 1 or an 11. Jack, queen, king are all treated as tens. But I want the logic for that to be somewhere else because the logic for that depends on the 2 cards in the player's hand. So I'm not going to think about that here. By the way, let me ask you guys, for the sake of doing this, how do you guys prefer this? Do you prefer me to just sit here and build the whole program and commentate it? Or do you want me to do the thing where I was doing where I stop and I ask questions and I try to get you guys like involved in the thinking process? What works best for you guys? Stop and ask questions? Okay. So we'll keep doing this. We'll keep doing it the way I've been doing it. You go away. Sorry, I hate Zoom's share screen interface stuff. A little both, yeah. Okay. So we built the card object. I know it might not, like some of it might be confusing to you guys. Like you don't understand, maybe in your head you're thinking you'd go about it a different way. And that's okay, but you also haven't seen the full implementation yet. So just, I have the cards now. I'm also going to make a deck object. So basically what a deck object is going to do, public or private card, I'm going to have an array of card, and it's going to be called cards. And we'll just initialize that to new card. There's going to be 52 of them. So here's what's going to happen. Public deck, the default constructor. And I'm just going to do this, split into 2 screens, just so I can reference this easily. Public void set suit, and I'm just going to do this with an int I. Let's say suit is equal to suits at I. We don't really need to manually feed it a string. I mean, I could do it with one extra layer. I could say set suit is like, I want to take a string, and I can have a separate method here that queries the array. But why do that? That's just an extra layer that I don't need. Does anybody have questions about that? Does anyone want to see both ways? Just let me know. Because it might be basic to me, but to you guys, it might be like mind-blowing, or just like something you guys haven't considered before. So I could stop and show. Or if you got it, we'll move on. Give me a thumbs up in the participants window if you got it. Thumbs down if you want to see it. Okay, most of you want to see it. Cool. I'll go ahead and show it then. So here's one way to do it. We're going to pause that. Or actually, I don't even need to have that. Here's a cool thing to teach you guys. There is something in Java called overloading methods. What that means is you can have a method with the same exact name and return value, But if the parameter is different, then these are two unique methods. This is a really, really cool feature of Java. And a lot of languages have this too. So I need to blow my nose real quick. Be right back. Okay. So what I was saying was overloading classes. These two, even though they have the same exact name and return value, they are Java considers them unique because they have different parameters. And it's not, so if I had just done this like int suit, then it would be a problem because these are exactly the same. The parameter name doesn't matter. But because it takes two different types of parameters, string, because it takes two different types of parameters, then we could do that. So if I were to do this, I would say this dot suit is equal to suit, and say public void get suits array. It suits at index, we'll call it int I, and we'll just say public string return suits at I. And I would do the same thing for values. And basically in here, instead of calling, so I'll show what I'm going to do here first. For int I equals 0. I think you can take 220 and 230 at the same time, unless they changed it. Which one was 230? CSC 230. Because I think 230 I think is discrete. Yeah, 230 is discrete math and 220 is data structures. They're not prereqs each other. I took them both at the same time. Here's one thing that I need. We'll just do it as constants here. That is okay. Private final int max suit index is equal to 4 because there's 4 of them. Called num suits to be more to be better named. Private final int num values is equal to 13. And the reason why I didn't name it index, this is a really minor thing, but the reason I didn't name it max index is because that gives the wrong impression to the reader. This is not, in fact, the max. This would not be the max index because if we try to query values 4, we'd get an error because there is no index 4 in a 4 element array. So, yeah. Discrete math is really, really easy, by the way, guys. I took it. It's not very difficult. It's just a very, very different way of thinking. It's going to be very confusing at the time, but just it's all training you to learn how to think with the computer. But anyways, all that aside, so all I is less than number of suits, I plus plus. I'm going to have a for int j is equal to 0. J is less than the number of values, j plus plus. And by the way, as I'm writing, if you guys have any questions at all, they could be even about like why I name things the way I do, or what formatting I'm using. Just shout it out. And what we also need to do is, how do we do this? 0 times 1, that's 0 times. No, it won't work. Int. I'm gonna just call this k. Oh, I'll call this k is equal to 0. And what I'm gonna do is cards at k is equal to new card with actually I'll break this out to be more explicit. So string suit is equal to, and let's say I didn't have this method. I'm going to comment this out. Let's say I didn't have that method. I'm going to say string suit is equal to card. Let's say new card dot get suit at index j. Or sorry, hold on. Set suit, and it would be a get suit index j. Oh, I'll just keep doing that. Oh, wait a second. I don't even need to do any of this. I don't need to do any of that. Why do I not need to do any of that, guys? Because I did something incredibly smart that I forgot about. Why do I not need to do any of that? Let's look at the methods over here in the card class. Why do I not need to do all the getter setter method that I was writing before? Any ideas? It's in the constructor. So initially I was writing getter setter methods for the student value. I do need the getter method for the value, but I don't need to set them. And why is that? They're already set in the array, but the public string is suit and value are not already set. Yeah, I know that the values are already set, but why do I not need to have methods to set these values? These two variables, suit and value, why do I not need a method to set them? I'm not asking about the arrays. I know the arrays are already set. Yes, Cameron is absolutely correct. And so is Mario. I have the parameters to use. I created my constructor with it in mind that in my deck constructor, I wanted to have an embedded for loop. And let's back up even further. Why did I design it like this to begin with? So we know why it works now. We see the implementation here, the use of it here. How did I know to initially do it like this? Why did I set it this way initially? Why didn't I do the other way? Why didn't I do the other way with having something like get value at index? Why didn't I do that? Why did I not do it this way around, like public void sets value, string value, this dot value equals value, and public void or public string get value at index. And I return values of I. Why did I not do it this way around? And then when I would call this, do like card dot set value. I'll just say object dot set value. No. I'm just saying, pretend I didn't have this. Pretend I didn't have any of this. Why did I make it? Why did I set it up this way instead of using these? Why did I go about this methodology instead of this methodology? Because both of these will work. Why? But why is one a little bit better than the other? Exactly, Aaron. I can have it in multiple constructors instead of having. I can have it in the constructor, one constructor, instead of like four to six methods. It's just shorter code. Look how much easier it is to read this thing. As soon as I pull it up, everything I need is right there. It's a very simple thing to read. So, and it also means I don't need to keep like a dummy cards object in tow, and I don't need to like keep creating a new card object every single time. Just for reference to the methods. Well, I mean, in that case, I would have built them as static methods, but that's a different story. If I wanted to do it the other way, I would have made this into a static method. So, what's this? By the way, we also don't need get value because I made the value and stuff public. So we're gonna say cards at k is equal to new card ij. And then we're just going to increment k after that. And bam! After I do this, I am going to have a deck of 52 cards. So let's write some methods in here. What's one thing I need to do from the deck? I have a deck of 52 cards. Great. What do I need to do now?
Pick a random one.
Random one, perfect. Public, we're going to return a card. Deal random card. And what's going to happen is we're going to create import Java util random. I'm going to say int I is equal to new random. Actually, we'll just use math. And let me refresh myself on how to do math.random, Java math.random, and in range. Perfect. I'll say, I can just do this setting to copy the return. Let's say int math random. Max is going to be is it size inclusive? Most number can get us the minimum. And the math, highest number can get us max. Okay. So I'm going to say cards.length -1 is going to be our max minus the minimum, which is 0. Because the minimum index we should be able to get should be 0. Yeah, so since math.random returns some random number between 1.0 and 0.0 and 1.0, that's its lowest value, right? So if the max is 0, hold on, rand between 0 and n. Makes sense. Okay. Oh, actually, you know what? The random class would work better for this. Java utils random imports. And the reason why random works better here is just because like it creates an integer and it's just much easier to do this, right? So like our range is going to be what do you call it? Oh, fuck me. Random integer, random.nextInt returns a random integer between 0 and whatever parameter we give here, but it does not, like, this is not the max. So it random.nextInt generates a random int between 0 and param minus 1. So it does that. And then what we're going to say is with the card, I'm going to say cards at I set in play is equal to true. And then we'll say Boolean face up, and cards.I.set face up is equal to face up. So when I'm dealing a card, one card in blackjack is always face down. One of the dealer cards is always face down. So all that, and then we're going to return that card. Return cards at I. And I'm going to have a method here, public void reset. So we can reset the deck. So basically what that's going to do is let's practice a for each loop. For each object of card type, card in the cards collection. So for each object of type card that we're going to refer to as card in the cards array, that's what this array is doing. And so this for loop is doing, excuse me. We're going to say card dot set in play is equal to false, and card dot set face up is equal to false as well. Just set them back to the default ways. There is something problematic here. There is going to be a problem we're going to run into here. What do you guys think that problem might be? Who can guess? What about the random, Nabil? Be more specific. Be more explicit. And you can unmute yourself and talk if that's easier. What's problematic about the random? Yes, there is a chance that it might repeat the same card. So what do we have? What can we leverage that we can ensure that that doesn't happen? Yeah, exactly, Cameron. If the card is in play. So trying to think of a better way to do this. It's probably much more efficient. I can do it during a while loop. So while cards at I public Boolean gets in play, return in play, gets in play. While this is true, we are just going to repeat that. And then I'll just put a comment here, error handling to make sure we don't repeat. Let's find out what's going on with this guy on Discord. Guys, I'm not iLearn tech support. I can't see the submission button. I have no idea. Just email it to me. Yeah, I'm not tech support for iLearn, guys. I can't help with that much. If you're having problems like that, just email me with a screenshot of what's going on and be like, hey, I'm emailing it to you because I can't submit. And I'll be like, all right, that's fine. When you do that, there is a good chance that I totally forget that you email me. Whenever I get around to grading it, there's probably a good chance that I totally forget that you emailed it to me. I usually, in those circumstances, try to grade that one first. But if I forget, just remind me again, and I'll go and regrade. You don't need to freak out and send me like this big long email. Just be like, hey, I think you forgot, and refer me to the initial email. Just remind me that you emailed me, basically. It's in the syllabus, Ronnie. Okay. We have the reset. We can deal a random card. Does our deck need to do anything else? I don't think so. It does not need to do anything because basically in between every hand we're going to reset, but that's going to be in the logic when we get to it later. We're not worried about the logic at the moment. All we want right now, what the hell are you doing? Buddy, get in there. We're not worried about the logic right now. As you guys can see, like I'm just starting out building my very basic objects. These are my building blocks of my whole program. I don't need to worry too much about my logic right now. I just need to make sure that my individual objects on their own are doing what they're meant to do. So again, like with the object slides, I showed you guys that little bit from Rick and Morty with the robot that passes butter. You just imagine you're building a bunch of butter passing robots. You have all these robots, and you just have to think, okay, what is this thing's purpose? What does it have to do? What is the card's purpose? The card's purpose is to tell us what these values are. This is tell us what the card is, and it accomplishes that by it's different. I don't like that. It accomplishes that by using this method and by having these suit and values easily accessible. The deck is meant to have a deck of 52 cards that we're able to reference here. So I'm going to now, we're going to ignore, we're done with the deck and cards here, and now we need to make our players and our dealer's hand. So here's two ways I could do it. I could create two separate objects, and that's what I'm going to start to do, but I'm going to show you how we could create this in one object. So we're going to have a dealer object, and then we're going to have a player object after that. New player, and we're going to have a player object. So let's start out with the player. I don't think I need a construction. Let's just say, well, yeah, we'll just have that thing. We'll assume we'll have multiple players, right? Private string name, and then public player string name. This dot name is equal to name. And then we're going to have a array. Private is going to have a array hand of cards, an array. Hand is equal to new cards 2, because you can only have 2 cards at any given time in blackjack. Cool. And what I'm going to do is private int I is equal to 0. And you'll see how this is going to come into play in just 1 second. Public void add to hand card. And we're going to say hand at I is equal to card. And I'm going to have some error handling here as well. We're going to say if I is equal to, if I is less than 2, we'll say. If I is less than 2, we'll do that. Else, we shouldn't get here, but yeah, we'll only put it in if I is less than 2. And we'll just say I plus plus. That is the only way we'll do this. And if it's not, then we're not going to add it. That's probably a fault in our logic. And just by doing nothing, we should be avoiding most problems. So we're going to have an add to hand. And we don't have to worry about if it's face up or face down, because our dealer or deck object should be taking care of that for us when it deals. Or like whatever's going to invoke this deal random card method, that one is the one who's responsible for worrying about whether the card is face up or face down. So we don't have to worry about that in here. And then we'll have public void show hand, say some print name to uppercase has hand, and then in a new line we'll print a print ln or hand at 0, that to string plus and hand 1 to string. And it's okay to hard code these numbers because we're only ever gonna, we know the way it works. We only ever have two cards in any given hand. Okay. And then we're going to go to the dealer. And the dealer is going to be mostly the same. The body of the dealer is going to be mostly the same. We probably don't need a, I'm not going to write a constructor for it because we don't care about this dealer's name. The dealer is just the dealer. And then over here, we'll just say dealer's hand. So one thing we do need to do here is we need to check which one is face up and which one is face down. Can I do string card 1 is equal to hand 0 dot gets, hold on a second. public void get face up, turn face up, get face up. If it's face up, then we say hand 0 to string. Otherwise, what the fuck? It's true. What's wrong with this? Cannot. Oh, duh. So what I have here, string card2 is equal to, this is the same exact thing, but at hand 1. I always forget what the name of this is. Shoot. What is it called? What is, can do JavaScript inline if statements. I never forget what it's, what this is called. Ternary. It's called ternary operator, conditional operator. What this basically means, this translates to being if hand 0 dot get face up, and we'll put this in parentheses, then it's going to be then card 1 is equal to hand 0 dot to string, else card 1 is equal to those. That's basically what this means. That's what this thing translates out to be, is this if statement. But it's just why do we use this? It's like with most things in coding, it's much cleaner to read. It's much faster to read once when you understand what this means. So, I mean, if you read it, it kind of makes sense too. We're asking Java question like, hey, does hand 0 have this value to be true? Question mark. Okay, so if it does, this is what we're going to do. This is the value that we're going to assign to card 1. Otherwise, this is the value that we're going to assign to card 1. Cool? Make sense? Yeah? Cool. Cool. Now, let's look at these two classes real quick. Right now I have a player and dealer class separately, but could I make it one class? Do I necessarily need to have two separate classes? Could I make this one class, and what might be the pros and cons of doing that? Why would there be two show hands? Why can't I just use this exactly the same thing for the player? Who cares? I can just have a... How could I fix that? How could I fix that? So yes, you are correct that it's hard-coded here. So I would probably want to use this way of doing it, right? Because this is dynamic, while this on the left is static. Right? This is static because I have static means it's one thing. I've hard-coded the value here. But I could write that dynamically, can't I? Just by using this methodology over here. Oh, oops. say card 1 and card 2. So what might be the con of combining these classes? Can you guys think of any? Is there a con to making these be the same class? No. Ronnie, are you thinking I'm going to just copy this code from the right into the left? Because that's not what I'm going to do. Instead of having two separate objects, I'm going to create one object that can serve as both the player's hand and the dealer's hand, is what I'm getting at. It's not harder to maintain. In fact, it's easier because I went from having to maintain two objects to maintaining one. Imagine if you have to do two things, but now you have to do one. Which one's easier? The special dealing cards, but I guess you're having those fulfilled in the main. Yeah, Cameron. The game is going to be dealing the cards. The answer is, I'm going to give it another minute for yes and marinate. Is there a downside to this? Is there a downside to combining these two classes? Yeah, there isn't. There is no downside to it. All it means is I go from having to maintain two classes to maintaining one. So new Java class. And in fact, instead of rewriting it, making a brand new class, I'm just going to refactor this. And the way I do that is I can right-click it. I will right-click it and say refactor rename. And we'll call it hand. And then private string name name.toUppercase name's hand, and we'll just say public hand string name this.name is equal to name. Put some extra spaces there just for clarity. And we can just go ahead and delete the player class. Delete. Where is that? Delete. I show its hand, and let's calculate the hand value. Public int hand value. Now here's where it's going to get a little tacky because we got to consider if one of these is an ace. So first we want to check if both of those are face up. If hand 0 get face up and hand 1 get face up. If both of these cards are face up, and we're going to do the stuff in here. Else, what we're going to do here is just going to say card is equal to hand 0. Is hand 0's face up? If it is, then card is going to be hand 0. Otherwise, it's going to be hand 1. So basically, we're checking to see which one of these two is face up, and then we're going to assign that to our hand. So in here, we're going to say if they're both face up, if hand 0. So we'll say int val1, val2. If hand 0 dot value equals jack, or maybe kind of a big one, or queen. And a neat way to do this is to have a new line in your if statement like that, or if it's a king, then val1 is equal to 10. Else if hand 0 value equals ace, val1 is equal to 11. And I will change that here in just a second. Otherwise, what we're going to do, change string to int. I think that's just integer. Yeah, integer %. Else val1 is equal to integer.parse int. We're going to transform this string hand0.value into a integer. And then we're just going to repeat this for the second card. And this is all going to be val2. Hand one. Okay. And by default, we'll just set these to 0, 0. So we'll say if val1 equals 11 or val2 equals 11. So if either of these were an ace, if val1 plus val2, we need to grab let me think. Oh, int ace to 0, and I'm going to say ace is equal to 0. Oh, by default, we'll just say ace is equal to 0, and over here we're going to say ace equals 1. Come back over here. If val1 is equal to 11 or val2 is equal to 11, then what we're going to do is if val1 plus val2 is greater than 21, God damn it, no, that doesn't work. Well, that does kind of work, I guess. Here, we'll name it more clearly. Boolean card one is ace, and we'll just set that equal to true, and then over here it becomes false. If that happens, if card 1 is ace, val1 is equal to 1, else val2 is equal to 1. So this is kind of messy. I don't like how this looks. I really don't like having like 3 layers of if statements, but off the top of my head, I can't think of a better way to do this right now. There probably is a better way, but I don't feel like looking into it right now. Although, No, it does matter which one. Okay. And then after all of this, we're just going to return going to return val1 plus val2. So for this blackjack game, I'm not considering any anything like splitting or any stuff like that. I'm just going to assume that all you can do is hit, right? There's not going to be splits or double downs or anything like that, anything special like that. Otherwise, and actually to keep things neater, I'm going to pull this out of an if statement. Card is equal to face-up card, and if card dot value equals jack or queen or king, I'm gonna return 10, else if it's an ace, I'm gonna return 11. Otherwise, we're just gonna return all right, we'll just return card.value, oops, integer.parse int card.value. Cool. Alrighty. So big function, a lot of if statements in the beginning. You guys can ask questions, but I am going to continue on. If you have questions, put in the chat or just unmute yourself and ask. But we have like 20 more minutes, so I do got to keep this moving. There's an error somewhere in here. What does not like about this? What's the mistake? What's the error? I don't know what it's not liking. It's not telling me an error. Okay, we're just gonna keep moving on. Yeah, there's like a definite return to this, so.
Does something on the top right mention any errors?
What's that?
The weird square on the top right. They usually have things that list any errors. That's
it's got warnings. Initializer is redundant.
that seems to have fixed it.
No, okay. That's not an error, dummy. Why'd you give me red? That's not a red error. That's a yellow error. Stupid. Oops, we don't want a Kotlin class. Okay. I've got the dealer, I've got the player's hands. We can start making the game now. It's called blackjack. Public, static, void, main, string, args. So here's what's going to happen. Inside of this, first create our player and dealer objects. And we're just going to assume we only have one of each. And for references, I'm just going to keep these over here. So how do I differentiate? Because there's only one hand object, how do I differentiate between my dealer and the player? How do I know which hand object is the dealer, which hand object is the player? Anyone? Anyone at all? There's an even easier way to do that, Cameron. I'm going to give it another minute. If no one comes up with it, I'll just tell you. And this is sort of a read my mind question. You are right in that, like, that is one way I could do it, but the easier way is and player. We just name these variables player and dealer, and then we know which one is which. String, oops, import Java util scanner. Scanner sc equals new scanner system.in. What is your name? And then new hand sc dot next line. Cool. And then hand dealer is equal to new hand dealer. That is literally all we have to do. We know which one is dealer and player because we are the programmer, we define the logic, and we have named our two variables very clearly. So, first thing that needs to happen, first up, deal cards. So what's going to happen is dealer is going to get one face down, player is going to get one face up, dealer is going to get one face up. So, oh, we should also create a new deck object. We also need to create all the objects that we need in here. So deck is equal to new deck object. And then from here, we're going to say, do we have a, yeah, add to hand, perfect. So we're gonna say dealer, add to hand, deck.deal random card, and it's gonna be face down. Then we're gonna give that to the player. And then we're gonna give another one face up to the dealer. So we have dealt our first cards. And I'm gonna have a method. Okay. So while Boolean is hitting or true. While is hitting it's now print your hand is a player dot hand value. And what should I? Your hand is player dot show hand. I should just say return that. We'll return it as a string. Oh. I'll just say toString instead of hand. Player dot toString. And then in parentheses, we're going to have the player dot hand value. So that's how it'll show them what their hand's value is. Print, do you want to hit or stay? and if okay, I'm not gonna do error checker. I'm just gonna assume that our player is gonna say hit or stay. So I'm not gonna have to worry about thing. And we'll just say if string input is equal to sc.nextLine, and then if input to uppercase equals stay, then is hitting equals false. Actually, I'll say well true, and if they stay, we're going to break out of the loop. Otherwise, they're going to get a new card. So player.add to hand. Actually, if another way we do also do is else if if player dot hand value is less than 21, oh, hold on a second, sorry. If it's less than 21, else if player dot hand value is equal to 21, you won. Actually, I want to have a while loop within a while loop. While true. And all this here is going to scoot over one. This break will only break us out of this while loop in here. You won. Break. And otherwise, if neither of these are true, meaning our hand value is greater than 21, system out print, you bust, dealer wins. So this outer while loop is the game loop, and this inner while loop is the hit stay loop. And once when we finish both of those, by the way, I know some people had questions about comments. This is really all you need for comments. The comments should just be like just sections labeled, or you know, for you guys as students, if you have questions about like something you don't understand how it works, or you were like, if you leave me a comment like, hey, I tried to do this, but I couldn't get it to work, and you just like kind of like talk it through it a little bit, you know, to try and like get some extra points, or to try and lose less points, that's okay. But yeah, your comments, some of you put comments in every single line telling me what the next line does. I don't need you to do that. I can read your next line. Really, your comments should just be here to kind of enhance. Think of your comments as black truffle. You don't want to just throw it all over the place. You want a little bit of it to add some flavor, right? So think of it like that. Anyways, on we go, because we've only got 10 minutes left to make this work. So after that, we're going to deck.reset, and we're gonna ask the player, do you want to keep playing? Yes or no. If sc.nextLine to uppercase equals yes, or equals no, then we break. We break out of the main loop. Otherwise, we're going to keep playing. Cool. And by the way, I do little things like this where I just, instead of having this be a variable and then an if query on it, I just have it in one. It doesn't really matter. This doesn't like make a huge difference in your optimizing or anything. I just do it to have less lines of code. That's it. But if you're confused by it, you can easily just break this up into two, and that's also totally fine. Just like I did here, I'm just showing you both ways of doing something. One is not inherently better than the other. It's up to you as the programmer to judge which one is easier to read. And if this version is easier to read for you, then do that version. And that should be it for our blackjack game. So all that's left is to run it. Edit configurations, new application, we can name it blackjack. Blackjack, okay, and if we run it, hopefully it'll work the first time. Taking a long ass time to build. Very nervous that it's going to break on the first run around. Yeah, and yes, it breaks. Card number 12 from deck 14. From John 7. Okay, this is a great example of how to debug your code. So what happens is you get an error here. And usually the nice thing about Java is a lot of the errors are pretty easy to read because they're verbose. But if you don't know what this error means, all you have to do is Google it. So you don't have to message me with every single error you get. You can come here and it'll tell you exactly what it is. Thrown to indicate that an array has was accessed with an illegal index. The index is either negative or greater than or equal to the size of the array. Cool, now we know what that is. And then it has a stack here. So it works its way backwards. So where the actual collision happened is here at iSuit. And then the one that called the problematic one is here, number of values. And then the one that called that is here. So when we called new deck, it started running this. Somewhere along the way, this call here accessed an illegal array size, which triggered the array at line 12, which is the suit. So the suits have been having illegal sizes. So what we do is we put a breakpoint there, and we run with the debugger. I'm actually going to put another breakpoint over there. Okay. Went all the way through. So I is equal to 0, k is equal to 0, k is equal to 1, j is equal to 1. That is okay. That is okay. Oh, wait. 4-0. I didn't see what that was. It was 4-0 something. So I'll run that again. So k at like 4. I think I know the problem. Value suit. Aha, ha, 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 ha. That is the problem. These are backwards. This should be ji, because j is the values, I is the suit. Now we should not have that problem. Perfect. My name is Turk. Null pointer exception. Oh. Here's what we can do. I'm gonna try that. Actually, I'm gonna try both. And I'm gonna pull these out here. Catch. With the exception of the null pointer exception. So we have an error. So the way the try catch block work is we have a try block here. We're going to say, I want to try this. And if while executing this code, I get an error of type null pointer exception, and I'm going to reference that as E or error, whatever you want to call it. I usually just call it E. Then I'm just not going to do anything. And we're not going to worry about it. Because by default, it's going to say that by default, it'll just be that. And if we don't do anything here, then all that means is all that really means is one of these is going to have like a dot, dot, dot on the side. But basically, what happens with the try catch block is instead of your program just crashing when it encounters an error, you can tell it to just keep going. And the nice thing about it is you can handle different errors. So let's say in this block, I'm like, okay, one thing that can happen is I can have a null pointer exception. Another thing that could maybe happen is an array index out of bounds exception. I'm gonna just say like, and we'll exit gracefully. Exit gracefully. So rather than the program just shutting down out of nowhere, we'll just say a fatal error was encountered, shutting down, and we'll just say system.exit with 1, because 1 means that there was an error. Is there a purpose for the E at the end? Yeah, the E is how this is just the type. Null pointer exception is just a type. It is a, we have an exception of type null pointer exception, and I'm going to reference that as E. So what I could do is E.print stack trace, and it would print out basically this. So E is an error object that has specific methods and stuff within it. We'll get more into try catching later. Just know that E just references to the error itself. I'm not using it in any of these because I'm not printing out. And in fact, here we'll just say E.print stack trace. And then we'll exit with the status of 1. This is, it doesn't help us, but it basically helps us exit gracefully. We give the user some kind of feedback of what's going on. That's what we're doing here. You don't really need to, I don't think our logic is ever going to get to that. I just have it as an example. That is literally just there to be an example. I'll leave it. Okay, so let's try running this again. The E, to answer your question more simply, Ronnie, this E serves the same role as this, or a parameter name does. It's just a reference. Damn it. For fuck's sake. Okay. try all of this. And catch null pointer exception E. I'm just going to return val1 plus val2. Whatever we've gotten at the time. Actually, you know what? You know, I do need to do this separately because val1 and val2 will not. Actually, the values I send them will persist. So I could just delete this. Wait, no, I do it like this. I do it out here. I'm just not going to do anything if I encounter a null pointer exception. I don't want it to shut down my program. I just want to keep it going. These are literally, this is bad practice. I'm literally just intentionally crashing my program and just saying, fuck it, go on. Because I was too lazy to have checks before. This is not very good practice. This is really just like duct tape solutions. Same thing here. Oh. God damn it. Try. Oops. I broke my code. God damn it. Okay. You know what? Screw it. I'll fix it another day. Class is over. I wrote this so like haphazardly. I totally forgot in the beginning. The cards values are going to be 0 for each. God dang it. Okay. So here's what's going to happen. Section 7. I'm going to do this again with section 2. But knowing what I know now, I'm going to write better code. So if you're watching this in the future in the recording and you want to see how to actually like write this program, I'll also post the code once when I fixed it. But just go look it up on section 2's. Just look it up on my YouTube, but watch the other section's video, and that's how you'll know. Because I totally forgot. I spaced out. Okay.